Hi students! Previously we have studied about what are arithmetic progressions and what are geometric progressions. Now in this lecture we are going to study about the third important progressions, which is the harmonic progressions. What exactly are harmonic progressions and what are the properties of terms which are in harmonic progressions? Further, we are going to study how to calculate the sum of n natural numbers, the sum of squares of n natural numbers, and also the sum of cubes of n natural numbers. Also, we are going to solve a few examples to understand these properties more clearly. Now, this is a sequence in which the terms are 1, 3, 5, 7, 9, 11. Now, what kind of progression is this? Of course, we see that the difference between 3 and 1 is equal to 2. The difference between 5 and 3 is also equal to 2. Difference between 7 and 5 is equal to 2. The difference between 9 and 7 is also equal to 2, and the difference between 11 and 9 is also equal to 2. Thus, this is an example of an AP, arithmetic progression, because the difference between the successive terms is constant and this is equal to the common difference. Let's look at one more sequence. It is 1, 2, 4, 8, 16, 32 and so on. Here we see that 2 divided by 1 is equal to 2, 4 divided by 2 is equal to 2, 8 divided by 4 is equal to 2 and so on. Thus, this is an example of a GP, geometric progression. Here the common ratio is equal to 2. Now let's look at one more sequence, which is 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. Now what type of progression is this? Is it an AP? No. Is it a GP? No. Then what kind of progression it is? The answer to this is the harmonic progression. This type of sequence is known as a harmonic progression. But now, what's so special about a harmonic progression? Let's see the definition of it. A sequence in which the reciprocals of the terms are in arithmetical progression is known as harmonic progression. So, it is a kind of sequence in which the reciprocals of the terms are in arithmetical progression. So, if we have a harmonic progression, then the reciprocal of the terms are in arithmetical progression. Let's try to understand this. We have a progression 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. Now, if we take the reciprocal of the first term, then it is 1. If we take the reciprocal of 1 by 2, it is 2. The reciprocal of 1 by 3 is 3. The reciprocal of 1 by 4 is 4. And the reciprocal of 1 by 5 is 5. Now, the difference between 1 and 2 is 1, 3 and 2 is also 1, 4 and 3 is 1, and 5 and 4 is also 1. Thus, we see that the difference between the successive terms is constant and that is equal to 1. So, this is an AP. 1, 2, 3, 4, 5 forms an AP. And so, this is a harmonic progression. That is, the reciprocal of the terms is an AP or arithmetical progression. Now, let's see the terms of a series in HP. HP is harmonic progression. What is a general term in HP? 1 by A, 1 by A plus D, 1 by A plus 2D, 1 by A plus 3D up to 1 by A plus n minus 1 into D are the terms of a series in HP. Because when we take the reciprocal of each of these terms, we get an AP, and so these form the terms of harmonic progression. Now, the general term would be 1 by A plus n minus 1 into D. The reciprocal of this term is A plus n minus 1 into D, and this is the general term of AP. So, the general term of HP would be 1 by general term of AP, which is 1 by A plus n minus 1 into D. So, this is a general term of HP, which is harmonic progression. Now, let's try to solve an example. Find the seventh term of the series 1 by 2, 2 by 7, 1 by 5, 2 by 13 and so on. So, we have a series in which we have to find the seventh term. So, let's look at the solution of this problem. The given series is 1 by 2, 2 by 7, 1 by 5, 2 by 13. So, these are the terms of the series. Now, what we do is we find the reciprocal of these terms. The reciprocals would be 2, 7 by 2, 5, 13 by 2 and so on. So, these are the reciprocals of these terms. Now, this is an AP. Why? Because the difference between the successive terms is constant. So your common difference is equal to 7 by 2 minus 2, which is equal to 3 by 2. Also the difference between 5 and 7 by 2 is equal to 3 by 2. Thus the common difference of this AP is equal to 3 by 2. Now the seventh term of this AP would be 2 plus 7 minus 1 into 3 by 2. Here the common difference is 3 by 2. First term is 2 and we have to find out the seventh term. So n would be equal to 7. So this comes out to be equal to 11. Thus the seventh term of this AP is equal to 11. We also know that the reciprocal of terms of HP are in AP. So the reciprocal of this term would be the seventh term of this HP. Thus the seventh term of HP would be reciprocal of 11, and which is equal to 1 by 11. Thus the seventh term of the series 1 by 2, 2 by 7, 1 by 5, 2 by 13 and so on is equal to 1 by 11. Let's try to solve an IT problem based on the concept of harmonic progression. This problem appeared in IITJ 2004 and it says that let A1, A2 and so on up to A10 be in AP and H1, H2 and so on up to H10 be in HP, which is the harmonic progression. If A1 is equal to H1 equal to 2 and A10 is equal to H10 equal to 3, then the value of A4 into H7 is option number A is 2, option number B is 3, option number C is 5 and option number D is 6. So in this problem we have been given that A1, A2 and so on up to A10 are the terms in AP, and similarly H1, H2 up to H10 are the terms in HP. Now it has been given that A1 is equal to H1 and both are equal to 2 and A10 is equal to H10 and both are equal to 3, and we have to find out the value of A4 into H7 and 4 options have been given to us.